Last week, we started introducing acids and bases. We looked at their definitions and we looked at properties of acids and bases. This week, we're going to talk about quantitative observations and descriptions of acids and bases. We'll do calculations to determine the concentration of ions in an acid and a base. We'll do calculations to identify the pH or the pOH, and we will do titration calculations. Today, we're going to talk about the self-ionization of water. And so when you have two water molecules, they produce a hydronium ion and a hydroxide ion by the transfer of a proton. And so I will draw this out. I'll write out the equation and I'll draw the Lewis structure so you can see what exactly going on. But since the water molecules are producing ions, water is a weak electrolyte. And so that means water will conduct electricity. We talked about electrolytes back in the solution unit, and we also showed you in the demos and videos last week that acids are electrolytes. We had the lemon clock, and bases are electrolytes. They will conduct electricity. Water is also a weak electrolyte because it produces ions in solution. And so to show you the equation, I'm going to two water molecules. They're both liquids. And I think it's helpful to draw the Lewis structures. Let me give myself a little more room in here to do that. And so you have the transfer of a proton from one water molecule to another. When that happens, we produce a hydronium ion in solution and a hydroxide ion in solution. And so at 25 degrees Celsius, the concentration of hydronium ions equals the concentration of hydroxide anions. And so they're both equal to 1.0 times 10 to the negative 7th molar. And so we can use this to come up with an equilibrium constant for water, which is the concentration of hydronium ions times the concentration of hydroxide ions and Kw is equal to 1.0 times 10 to the negative 14. So that means that 1.0 times 10 to the negative 14 equals the concentration of hydronium ions times the concentration of hydroxide ions. So we can use this Kw expression to solve. If you knew the concentration of hydronium ions, you could use this Kw expression to solve for hydroxide. And if you know the concentration of hydroxide ions, you can use Kw to solve for the concentration of hydronium. And we will do some example problems today. And so before we do some example problems, I just want to show you, compare in an acidic, neutral, and basic solution, how much hydronium ions you have compared to how much hydroxide. So in a acidic solution, the one on the left, the concentration of hydronium ions is greater than the concentration of hydroxide ions if it's acidic. And so these are images of seesaws. So on the left, there's more hydronium, so it's showing you that it's larger and that side is down. If it's a neutral solution, the concentration of hydronium ions and the concentration of hydroxide ions are equal, and they're both equal to 1.0 times 10 to the negative 7th molar. If it is a basic solution, you can see there's more hydroxide than hydronium in the solution. So basic solutions have high hydroxide ion concentrations. Acidic solutions have high hydronium ion concentrations. So we're going to do some problems with KW, and we're going to start by building a graphic organizer to help you, like a way to do all these conversions. Today, we're just converting between hydronium ion concentration to hydroxide ion concentration. And for these conversions, you'll use KW, which is 1.0 times 10 to the negative 14, which equals the concentration of hydronium ions times the concentration of hydroxide ions. I do want to remind you, wherever you've seen these brackets, that equals concentration. So I'm going to do two problems, walk through them with you, and then I'll have, after I do the two problems, I will have you do two, and then we'll check the answers. So the first problem, I have the concentration of hydronium ions at 3.00 times 10 to the negative 5th molar. I want to find the concentration of hydroxide ions. So I'm going to use the KW expression, hydronium ion concentration times hydroxide ion concentration equals 1.0 times 10 to the negative 14. Then I have my concentration of hydronium ions. I'm going to plug that number in here. I'm going to solve for the hydroxide ion concentration by dividing both sides by 3.00 times 10 to the negative 5th molar. You don't have to show, what you would have to show on your assignments, on your test next week, would be this, the numbers plugged in, and then the answer with correct units and sig figs. You don't have to show me the dividing. I'm just doing that for this first problem to show you how I solve for it. That cancels. So my concentration of hydroxide ions. Remember when you plug this into your calculator, so you're going to need to use scientific notation. So I would type in 1.0 second, and then the x to the negative 1 button, which is above the 7, so that I have an e, and then negative 14. So your calculator should read 1.0 e negative 14. Do not use a caret. Do not type in times 10. Your calculator should just say 1.0 e to the negative 14. and I'm going to divide by 3.00 e to the negative fifth. And so I do need to round for sig figs. When you divide, it's the least number of sig figs. So I should have 2 sig figs in my answer. So I get 3.3 times 10 to the negative 10th. And this is a concentration, so molarity, molar. So we're going to do the next problem. In the next problem, I have hydroxide ions. I want to find hydronium ions. So I'm going to take I'm going to write down my expression for Kw. This is what I would expect to see on your homework. You're going to get a review today for chapter 14. I would expect to see this as part of your work. And then on your test next Monday, I would expect to see this as part of your work. I'm going to plug in the number for the hydroxide ion concentration. And so I would expect to see the numbers plugged in to your value. And again, you're going to plug in, you're going to use your calculator to divide. And you would need 2 sig figs. So the hydronium ion concentration here is 1.3 times 10 to the negative 9th molar. So there are going to be 2 problems I'm going to put up on the screen. If you don't have a calculator, you're going to need to make sure you get a calculator out. I want you to do the next 2 problems, work through them, and then with someone next to you, I want you to check your answers and make sure they're right. And then I will go over them. So I want the video to be paused while you work through problems C and D. And then after about 5 or 6 minutes, you can restart the video and go over these problems. So try problem C and D. Okay, so you should have done problem C and D and checked with your partners or check with someone around you. I'm going to go over the correct answers now. In C, I have the hydronium ion concentration. I want to find the hydroxide ion concentration. So I'm going to write my expression for Kw. I'm going to plug in my number for the concentration of hydronium ions. And then use my calculator. I need 2 sig figs. So I get 3.7 times 10 to the negative 10th molar concentration of hydroxide ions for C. For the next problem, I have hydroxide ion concentration. I'm going to find hydronium. So I'm using my Kw expression. I'm going to plug in my number for the hydroxide ion concentration. And then I need 2 sig figs, so it's 1.5 times 10 to the negative 5th molar. So you're going to get a review guide for the chapter 14-15 test today, and it's also the review guide for the final exam. The next 2 slides in the PowerPoint will go over reminders for this week and talk about the final exam. If you have questions, please message Mrs. Chapman in Schoology, or you can even stop by room 335. Thanks.